last video, we looked at special right triangles that had to do with sides, where the sides were nice integers, like the 3, 4, 5, the 6, 8, 10, or the 5, 12, 13, and so forth. Now we're going to look at special right triangles that have to do with the angles. Okay, and by the way, these never overlap. If it's a special right, a 5, 12, 13 will never be a special right triangle with angles, okay? That never works out. But so here, if we look at a 45, 45, 90, okay, the angles, right? The angles add up to 180, which is the way it has to be. Okay, if you notice, if we just let one of the sides, if we call these legs, and if this leg opposite this 45 is A, then we should realize this is an isosceles triangle and the two legs are equal. Therefore, the other leg would also be equal to A. Okay, and then the hypotenuse, we don't know what that is. We would like to get that in terms of A, so we're going to call it H for now. Okay, so we're going to come up with a connection between the sides that'll be always true. Okay, so if we write Pythagorean's theorem, now Pythagorean's theorem says that the hypotenuse squared is equal to the sum of the legs squared. Okay, and so the way we've labeled it, it is H squared equals A squared plus A squared. And then if we just go ahead and do the algebra here, H squared, this would be 2A. H squared is equal to 2A squared. H is equal to plus or minus the square root of 2A squared. So H is equal to, remember, it has to be the positive because it's a length, square root of 2, and A squared, square root of A squared is A. So you can see now that the hypotenuse is going to be equal to root 2 times A. So that says in a 45, 45, 90 triangle, the sides are the leg hypotenuse. They're in a ratio of A to A root 2, or more simply, the ratio of 1 to 1 to root 2, if we just divide through by A. Because you notice, no matter what happens in this triangle, if I change the size, the relationship stays the same, okay? There's the same scale because they're similar triangles. Remember, all 45, 45, 90s are similar because the angles of one are equal. All the angles are equal, and so therefore their sides are always in the same ratios. Okay, so the special 45, 45, 90 relationship is a 1, 1, root 2. Okay, now an easy way to remember that, if you forget that, it's not hard to do. I mean, you should realize this is isosceles, so if I just let each of the legs equal 1, and then I could simply do Pythagorean's theorem real quick. I mean, it doesn't take much work to do here. H becomes the square root of 2. So that's the relationship, okay? So no matter what the leg is, the hypotenuse is the square root of 2 times it, and obviously the legs are equal, okay? So you can see here, if I have a picture here, this is the way it works. No matter, I can change the leg. The leg right now is 1, and so the legs are equal. You just multiply the legs, whatever value, by 1, and then whatever that value is, you multiply it by root 2. In other words, if I change this to 5, if I'm changing the ratio, then the leg is going to be 1 times 5, 1 times 5, and the hypotenuse would be root 2 times 5. So whatever that is. So if the leg was 7, so the leg is 7, the legs are 7, then the hypotenuse would be 7 root 2. That's very simple, okay? So let's go ahead and do some examples on this. So here I have here's the 45, 45, 90. So you should realize, and if you think of it this way, the connection between the leg and hypotenuse is root 2. Okay, the connection between the legs are simply 1. So if I'm going from a leg to the hypotenuse, I multiply by root 2. If I'm going from the hypotenuse to the leg, it gets smaller. Remember, the hypotenuse is the largest size. I divide by root 2. And of course, going from leg to leg, they're the same. So let's see here. Suppose that I'm just giving the value of the leg. So here's what I'm saying. If the leg is 9, then obviously the other leg is 9. And then the hypotenuse would be 9 times root 2, which is about 12.73. So no matter what I change it to, if I change the hypotenuse to, the leg to 3, the other leg is 3, and then the hypotenuse is root 2 times 3, which is about 4. You could leave it as 3 root 2, obviously, but I'm just giving you an idea. It's approximately 4.24. Okay, that's what's going on there. Now let's see what happens if I have the hypotenuse. If I'm given the hypotenuse, now the hypotenuse is 2. To get to the leg, then it gets smaller. So the key is root 2. I divide by root 2 because it's going to get smaller. So going from the leg to the hypotenuse, I multiply by root 2. Going from the hypotenuse to the leg, I divide by root 2. So if the hypotenuse is 2, then the leg is 2 divided by root 2, which is approximately 1.41. And then obviously the other leg is 1.41. So if I change the hypotenuse to 7, okay, then the legs would be, you divide by root 2. And again, you can leave it as 7 divided by root 2, or you can rationalize if you wish, or if you're using a calculator, it would just become 4.95 approximately. Okay, that's all you have to do. So that's a special numbers that go with a 45, 45, 90. So let's do some examples here. So here's a 45, 45, 90. Remember, it has to be a right triangle, and it has to have a 45-degree angle. If I let the leg, one leg is 4. If I want to find out what the other sides are, going to the other leg, they're equal, so I just put a 4 there. And then if I want to go to the hypotenuse, I must multiply it by root 2, so the hypotenuse is 4 root 2. That's all you have to do. You have to know these numbers, though. The numbers are basically 1, these are equal, and a root 2. That's the numbers for 45, 45. And remember, if you forget it, if you put a 1 here for one leg, the other leg is 1, you could use Pythagoras' theorem and get a root 2. Then you'd remember the relationship, okay? It's good to understand that. So let's see here. Suppose the hypotenuse is 9 root 2. See, the hypotenuse is 9 root 2. So now if I want to go to the leg, I would simply divide by root 2. So now one of the legs is 9, obviously. You divide 9 root 2 by root 2, you get 9. And then the other leg is obviously 9 also. So you can get that information. It's very, very simple. Okay, so no matter what's going on, if I let the leg equal to 4 root 3, okay, then the other leg is obviously 4 root 3. And to go to the hypotenuse, I multiply. It's getting bigger. So I multiply by root 2, excuse me. So 4 root 3 times root 2 would be simply 4 root 6. Okay? So that's all you have to do. So that's what you're dealing with when you have these kind of trouble. If the hypotenuse is 25, to go to the legs, I divide by root 2. So it'd be 25. Now this time I've rationalized it for you. 25 divided by root 2. By the way, whenever you're doing stuff like this, don't try and jump steps ahead. Write down this, because you're simply taking 25 and dividing it by root 2, which is a correct answer. It's just not rationalized. If you wanted to rationalize, sometimes you don't. And then you rationalize it. We multiply it by 1 in the form of root 2 over root 2, because this becomes 2 in the denominator. We got the radical out of the denominator is what we're doing, okay? So that's how you do that. And then the other leg, obviously, would be 25 root 2. Okay, what I'm trying to do is give you ways of remembering or to develop the special numbers that go with the 30, 60, 90 and the 45, 45, 90. Okay, and so if you visualize it like the 45, 45, 90, it's 1, 1, root 2. If you forget it, you should be able to develop that. And now we're going to go see if we can develop the special numbers for a 30, 60, 90. We use these special right triangles quite often when we're dealing with trig. So you have to understand these relationships and in order to use them, okay? So the way to start, now the triangle doesn't look correct, that's why I put this green color D inside here. If we have this is an equilateral triangle. It is isosceles also, but it's equilateral because all the angles are 60. This is 60, 60. Well, that's 120, so that has to be 60. And then, so therefore, all the sides are equal, okay? So if we're going to start with that, so if I was to show, if I were doing this, I'm going to call the sides 2s. Okay, because I'm going to develop it. It makes it easier to develop it this way. So the sides are 2s, and then what I'm going to do is hide the triangle, and I'm going to drop an altitude. Now you should realize this is an isosceles triangle also. So if I drop an altitude from the vertex of an isosceles triangle, it is perpendicular to the base. It bisects the base. These two pieces are equal, and it bisects this angle, the vertex angle. Okay, you should know this from geometry, but it looks like it bisects. It should make sense to you, okay? And by doing that then, what happens now is I'm looking at this simple triangle, and this is the way you can develop the numbers that go with the 30, 60, 90. So you can see here the hypotenuse is 2s. That's the hypotenuse is 2s. And then if I go ahead, this is what we call the short leg down here. The short leg, remember the shortest leg is opposite the smallest angle. the long leg is opposite the bigger angle, and the hypotenuse obviously is the biggest of them all because that's the biggest angle in this triangle. Okay, so this would be simply S because it bisects the base here when we drop this altitude. So if this is 2S, this is S. So it makes it a little simpler. Now the hard one to do is find the altitude, but it's not hard. We just use Pythagorean's theorem. And so we're going to call it A for the time being. And we'll just do Pythagorean's theorem. And we want to get A, in this case, in terms of S, so that we have a relationship between the three sides. And again, these triangles, remember, are always similar because the angles are always the same. So these ratios are always the same. So now if I use Pythagorean's theorem, the hypotenuse squared, the hypotenuse is 2S. So 2S squared is equal to one leg. This leg, the long leg in this case, is A squared. And the short leg is S, so that would be S squared. And that's Pythagorean's theorem. Now I'm going to, remember, I'm solving for A in terms of S because I want the three sides in terms of S. So then I just go ahead, this is 4S squared equals A squared, this plus S squared. If I collect my S's, I get A squared equals, this becomes 3S squared. So A is equal to the square root. Again, it would be plus and minus. There's always two solutions. It's a good thing. Always keep that in mind. So this becomes root 3S. So that's the relationship, okay? So therefore now the third side, so the relationship of a 30, 60, 90, the sides are always in this ratio, okay? It's going to be S to S root 3 to 2S. And if you divide through by S, if you just rationalize this, it becomes 1 to root 3 to 2. Okay, and that is the special numbers for 30, 60, 90. So you need to know those relationships. So just like with the 45, 45, 90. And just as a note, root 3 is about 1.732. Again, don't confuse it. Remember, the hypotenuse is the biggest, and root 4 is 2, so root 3 is less, obviously. So they are in the proper sizes, okay? And again, if you need to remember that, if you just hopefully if you can remember the relationship between, if you can picture this picture here, an equilateral triangle, and have the hypotenuse or the sides as 2S, drop in altitude, this would be, excuse me, this is, make it a 2, make this a 1. It would be very easy to use Pythagorean's theorem to get the long leg. You get root 3. So you can get those special numbers. I'm just trying to get you, you really have to know these numbers, and you have to, if you memorize, I know if I try to memorize, I'd get my root 3s confused with root 2 for the 45, 45, 90. So you got to try and do that, okay? So the deal is then, if I'm just looking at a 30, 60, 90, no matter what the short leg, and by the way, you always want to work in these problems to the short leg. Okay, whatever the short leg is, to get to the long leg, you multiply by root 3. And whatever if you want the hypotenuse, you multiply by 2. So you see if I change, right now the short leg is 3, so therefore the long leg would be 3 root 3, and the hypotenuse would be 2 times 3, or 6. If I change this to a 5, then the short leg is 5, the hypotenuse would be 2 times 5, or 10, the long leg would be 5 times root 3. No matter what you do, okay? Very similar to the 45, 45, 90, but just different numbers, okay? So again, the key is short, and again, you should always work to the short leg. If I'm given a hypotenuse and I want to go to the long leg, I would always go to the short leg first, then to the long leg. That would be my strategy. This way you don't have to remember any other numbers. So the connection short leg to hypotenuse is a 2. If I'm going this way, it gets longer, I multiply by 2. If I'm going the hypotenuse to the short leg, it gets shorter, so I divide by 2. If I'm going from the short leg to the long leg, it gets bigger, I multiply by root 3. Going from the long leg to the short leg, I divide by root 3. Okay, so let's just to see this. So if I start with the short leg is 12, okay, no matter what it is, to get to the hypotenuse, I multiply it by 2, would be 24. To get to the long leg, I multiply it by root 3, which would be the short leg times root 3, which is approximately 20.78. So no matter what I make the short leg, if I make the short leg 5, the hypotenuse is 10, and the long leg would be root 3 times 5, or approximately 8.66. That's all you have to realize. You get these numbers going, and that works out pretty nicely, okay? If I start with the long leg, by the way, I always want to work to the short leg, okay? Because I know the relationship from the long leg to the short leg, I would have to divide by root 3. So if the long leg was 1, if I divide by root 3, this is going to be, the short leg would be 1 divided by root 3, which is approximately 0.58. And then from the short leg, I'm going to go to the hypotenuse, which means multiply it by 2. So I'd go from here, divide by root 3, multiply by 2. Okay, so let's make this number say 7. So if I make the long leg 7, if the long leg is 7, to go to the short leg, I divide it by root 3, and I get about 4.04. And then I multiply this by 2 to get to the hypotenuse, which is about 8.08. Okay? Whoops, sorry about that. If I start with the hypotenuse, I always want to go to the short leg. So if the hypotenuse is 1, to get to the short leg, I divide it by 2 because it's getting shorter. So I get a half or 0.5, and then go to the long leg from the short leg, multiply it by root 3, and you get 0.87. If the hypotenuse is 10, then going to the short leg, I divide by 2, I get 5. Multiplying by root 3 to get to the long leg, it's about 0.866. Okay, so let's go ahead and just do some examples with this again. So here's the problem, the short leg is 5. So I need to know then, to get to the hypotenuse, I would multiply it by 2. So it's 10. To get to the long leg, I multiply it by root 3, and it is 5 root 3. So you must understand those relationships, okay? If I start with the hypotenuse, if the hypotenuse is 16, remember I always want to go to the short leg, which is opposite the 31st, okay? Which means I divide it by 2, which it becomes 8. And then now I can go from the short leg to the long leg, which means I would multiply it by root 3. So the long leg is then 8 root 3. It is hard to go from the hypotenuse. I mean, it's not hard, but what I would have to do is remember the 2 steps. To me, it's much simpler. Always go the short leg. If you just remember these 2 numbers, it's very easy. Divide by 2, multiply by root 3. And that's all you have to do. Okay. If the long leg is 6 root 3, again, I want to go to the short leg first, which means I would divide it by root 3, so that's 6. And now I get to the hypotenuse. I multiply it by 2, and the hypotenuse becomes 12. Okay? And if I let the long leg be 21, to get to the short leg, I would divide it by root 3, and I rationalize it again. 21 divided by root 3. You can leave it this way, by the way, unless the question says rationalize. But just to know how to do this, you multiply it by 1 in the form of root 3 over root 3. So this gives me a 3, and then I end up with 21 root 3. Now the radical's in the numerator, and then the 3 goes into 21/7. So you get 7 root 3, and then going to the hypotenuse, you simply double that, which is 14 root 3. So those are the numbers you need to know for 45, 45, 90. It is 1, 1 root 2. For 30, 60, 90, it is 1 root 3, 2. Okay? That's what you got to remember.